Assalamu alaikum students. Today this is the second part of the application of differential calculus. So this video is made for this is the second video for application of differential calculus. So let me solve. So yesterday I have taken a class test on application of differential calculus. So let me solve this question. Let me show you how to solve this question. So in this question we have is a firm has the following total cost and demand function. So this is the cost function and this is the demand function, right? So question is asking find out the total revenue function in terms of Q. So the question is asking find out the total revenue function in terms of Q. So let us solve it now. So find out the total revenue function in terms of Q, right? So this is the demand function where Q is the variable. In this question it's asking find out the total revenue function in terms of Q. So that means in the revenue function only Q can be there, right? So here what we see revenue is equal to P price. That means revenue is equal to price multiplied by quantity, right? Price multiplied by quantity. So here price means P, and quantity means Q, right? But the question said that in the question only variable should be Q. From the question we can get an idea that in the revenue function should be in terms of Q. That means in the revenue function, in the question is saying that find out the total revenue function in terms of Q. That means in the revenue function only Q should be the variable. So that means we need to replace P. So to replace P, you need to find out the function or the formula or the equation for P. So you need to find P. What is P? So let us find what is P. So if you bring this one to left hand side, what we will have 0.5 P is equal to, and if you bring Q on the left hand side, we will have 600 minus Q. So we want to find out the P. So what we can do, we can multiply both side by 2. If you multiply these one by 2, we will get 0.5 multiplied by 2, that is 1 P. We will get 1 P, that means only P, right? Or if we had something else like 0.3, then what we would do? What we could do is we could bring these one to right hand side. And I'm going to show you how we will do it. So this one, to solve this one we can solve it very easily, because if you multiply both side by 2, you can easily get here you can get P, here you can get P, and here you can get 1200 minus 2Q very easily. That means if you multiply both side by 2, this one will be only P, and this one will be 1200 minus 2Q. But what if you had something else here? What if you had something like this here? So what if you had something like this here? In that case, what we had to do is 3. Like if you had a if you had a 0.3 here, if you had a 0.3 here, in that case what we would do, what we would have to do, we would have to bring this one to right hand side, and if you bring this one to right hand side, it will go in the lower part of the fraction, that is in the denominator. And then what we could do is we could write it like this way, we could write it like this way, is equal to, that means we could write it like 600 divided by 0.3 minus q divided by 0.3. we could write it like this way, right? That means like so if you divide 600 by 0.3, what will you get? You will get 2000 minus, and this one here, you can see there is a 1 here, we don't see there is a 1 here. So if you divide 1 by 0.3, so 1 divided by 0.3, so if you can write it like this way, so that means 1 divided by 0.3, and here you have q. So that means 1 divided by 0.3, 1 divided by 0.3, 1 divided by 0.3, which means 3 point, you can write it like 3.3333 q. So that means P is equal to, that means P is equal to this one, P is equal to this one. So you could write it like this way, you could write it like this way. But anyway, we don't have in this question, we don't have like this, we don't have like this, we have, what we have is 0.5p, what we have is 0.5p. so obviously, so we can multiply both side by 2, we can multiply both side by 2, so that means we will get, what we will get is, we will get p here, and the right hand side we will have 1200 minus 2q. so p is equal to 1200 minus 2q. Right, so here revenue is equal to PQ, so revenue is equal to PQ, so P means P is equal to 1200 minus 2Q, so P is equal to 1200, so 1200 minus 2Q multiplied by Q, which is equal to what? So 1200Q minus 2Q square, minus 2Q square, right? So 1200Q minus 2Q square, right? That's the revenue function. So that is the revenue function, right? The first question, and the second, so that's the revenue function, that's the revenue function. So we can write revenue function, right? So that's the revenue function, okay, right? So formulate the total profit function. Now the second question, formulate the total profit function in terms of Q. Second question, formulate the total profit function in terms of Q. So let us formulate the total profit function in terms of Q. Let us formulate the total profit function in terms of Q. So formulate the total profit function in terms of Q. So let us formulate the total profit function in terms of Q, right? So this is the revenue function, we can see, and the profit function, so profit is equal to, we know that profit means revenue minus cost, revenue minus cost. So profit is equal to revenue minus cost, we know that. So here revenue is 1200Q minus 2Q square. This is the revenue function minus bracket cost function. So minus bracket cost function, and here we can see this is the cost function. This is the cost function. So this is the cost function. We can see this is the cost function. So minus this one bracket is equal to, so we will just simplify now. What we have is, so as you can see here, there is a minus. This minus will be multiplied by everything inside. So that means everything inside will get sign changed. So sign of everything, sign of inside the bracket will change. So this one will become minus. This one will become minus. So that means this one will become plus. So right. Okay, so now what we will do, we will simplify, right? We will simplify. So as you can see, first we have 1200 Q. First we will have 1200 Q. We will deal with this 28.5 Q. So from 1200 we will deduct 28.5. So 1200 minus 28.5, what we will get? We will get, so from 1200 we will deduct 28.5. So we will get what? So this will not be there. So we will have 1171.5 Q. So this will no longer be there because we have already dealt with this one, right? So second, so now we will deal with, here we have minus 2Q square, here we have plus 81.25 plus 81.25 Q square, right? So 81.25 Q square minus 2Q square, that means we have what? 79.25 Q square. So we will have here plus 79.25 Q square. So that means here, so here we have 81.25 Q square, this is plus, and here minus 2Q square. So from 81.25 we will deduct 2, so we will have 79.25 Q square. So that means this will no longer be there. We have already dealt with this one. So remaining thing is as it is, right? So this is the profit function. This is the profit function. This is the profit function. So let us name it. Okay. So in finance and economics, the profit function is normally named as pi. In finance and economics, lots of Greek letter is used. So profit function is normally denoted by pi function. So obviously, I mean, you can, if you don't like the Greek letter, you can name the profit function with any name. So you can, by any name you can name it. Okay, this doesn't really matter. So here Q is the variable. From the bracket, you can see the inside the bracket we have Q. So Q is the variable. Right. So that's the answer for part B. Now the question is asking, find the profit maximizing. Find the profit maximizing level of output Q. So that means we need to find out the value of Q for which profit will be maximum. So here, this is the profit function. So this is the profit function we have, right? So that means if you want to find out the maximum point or minimum point, you need to find out the slope, right? That means at stationary point we know that slope is 0. So we know that at stationary point, so first find out the slope. Slope is equal to, slope will be equal to, slope means we need to do differentiation of this one. If you want to find out the slope, you need to do differentiation of this one. So this is the profit function. If you do differentiation of this one, you will get pi prime q is equal to so here q is the variable, so we will do differentiation of the profit function. We will do differentiation of this function with respect to q, so it's a very easy differentiation, obviously. Let's do it. So first of all, we have this part. If you do differentiation of this one, what we will get? 1171.5 plus, and then we have this one, this is the coefficient, and if you do differentiation of q square, you will get 2q, minus, this is the coefficient here, it will sit as it is, and if you do differentiation of q cube, you will get 3q square, right? So if you do differentiation of this one, you will get 3q square. Now if you do differentiation of this one, you will get 0, you will get minus 0. So you don't have to really write it anyway. So now what we have, so if you multiply these one, 79.25 multiplied by 2, 79.25 multiplied by 2, that is, we have is 158.5q, 158.5q, right? So 79.25 multiplied by 2, we have 158.5q, and 3 into 1.25, so we have 3.75. 3 into 1.25, we have 3.75. So 3.75 q square, 3.75 q square. So 3.75 q square, right? So this is the slope. This is the slope of the profit function. Right? So this is the slope of the profit function. We know that at stationary point, slope is 0. At stationary point, slope is 0. So which means this one equals to 0. This one will be equal to 0. So here, so you have to solve it like this way in the exam. Here, I mean, we want to, this is a second degree equation. Because here q is the variable, and over this variable, the highest power we have is square, right? So this is a second degree equation. Always remember, I mean, the squared variable, whatever coefficient you have with the squared variable, that's the value of a. That means you need to resemble this equation. with this one. You need to resemble this equation with this one. So that means this is, in this equation, x is the variable and this is the squared variable, and with this squared variable a is the coefficient. So if you match with these equation with this equation, what we can see, the value of A, so that means the value of A is minus 3.75, minus 3.75. The value of C, so value of A will be minus 3.75. That means here this is the variable, Q is the variable, and this is the squared variable. With the squared variable, whatever coefficient we will have, that's the value of A, right? And now B is here. If you match with this one, here this is the variable and without power. This is the variable without power, and this is the coefficient. So B. So now again, this is the variable without power, and this is the coefficient. This is the coefficient. So plus. So when there is a plus, you don't have to really write it. So we have what? 158.5. That's the value of B. So that's the value of B, right? So now we will find out the value of C. So C is the remaining part. C is the remaining part without the variable. So here this is the remaining part without the variable. So 1171.5, 1171.5. So if you match it with this one, you can solve it in two different ways. You can use this formula. The formula is minus B plus minus root over B square minus 2AC, B square minus 4AC, minus 4AC. So minus B plus minus B square minus 4AC divided by twice A. So this is the formula. So now here we want to find out the value of the variable. For us, X is the variable. That means here for us, Q is the variable. Q is the variable. If you want to find out the value of Q. To find out the value of Q, what we have to do, we need to put the values. We need to put these values in this formula. So always remember, you will get two values of the variable, because this is a second degree equation. Power is 2. Here the power is 2. So this is a second degree equation. If you solve it, you should always get two values of the variable, right? So you can use this formula to solve this equation, but we will, as I have taught you how to use your calculator to calculate this one, right? So use your calculator's mode function. Use your calculator's mode function. Press mode, and then if you are press mode and then choose equation mode, EQN mode. Press mode and then choose EQN mode. That means press 5. And then choose these equation, and then choose these equation. That means number 3. So now you press the values of, now you input the values of A. Input the value of A minus 3.75. The value of B is 158.5. C is 1171.5. Right. So let me check if I input the value correctly. Yes, minus 3.75, 158.5, and 1171.5. Right. So the value of X. So here actually, so you will get, as I said, you will get two values of the variable. So the first value of the variable, here Q is the variable. So first value of the variable is 48.6836. 6836. So 48.6836. And another value of the variable is, if you press equal again, you will get another value. Another value is minus, another value of the Q, another value of Q is minus 6.4169. 4169. It is customary to take, when you do business calculation, it is customary to consider up to 4 decimal point. as many, if you can take as many decimal as possible, that's much better. But you can take you must take up to 4 decimal point in the exam. That means after the point you need to take 4, you need to take 4 decimal, you need to take 4 numbers after point, right? So if you want to come back to normal mode, you are in the equation mode now. If you want to come back to normal mode in your calculator, press mode and then 1, you will come back to normal mode. So here this is the value of q, this is the value of the q. So pay attention, let's see whether we have any unit for q. No, we don't have any unit in the question, so we don't have to write the unit there. So this is the value of q, right? So this is the value of q. Remember, q is the quantity, q is the quantity. So quantity, you can write it is, quantity cannot be negative, quantity cannot be negative. So quantity cannot be negative, so the value of q should be this one. So the value of q should be this one. So negative value of quantity is not possible. So quantity will be, the value of quantity will be this one. Alright, so now part D, evidence, proof. So part D, we will prove it. So that means now we will move to part D. So we will prove it. So as you know, we can prove it using 2 different methods. First differentiation method or second differentiation method. You can prove it, you can prove this problem using first differentiation method or second differentiation method. Right. So let's prove it. So to prove it, we will need the slope function. We will need the slope function. So this is the slope function. This is the slope function. Right. This is the slope function. So we will prove it. We can prove it using first differentiation method. We can prove it using first differentiation method. So let us prove it. I'm going to show you the proof using both method. I'm going to show you the proof using both method. So let me prove it using first differentiation method first. Right, so this is the slope function. Obviously here at stationary point, value of q is what? At stationary point, value of q is, at stationary point, value of q is, at stationary point, value of q we got is 48.6836. So 48.6836. So 48.6836. That's the value we got at stationary point. That's the value 48.6836. So 48.6836. So that's the value. That's the value we got at stationary point. So you know that when you prove it using first differentiation method, you need to check the slope before the stationary point and check the slope after the stationary point. So what we will do, we will take, if we will say if q is equal to, if q is equal to 48, so that means before the stationary point, you can take any value lower than this one. So we can take 48. So if the value of q, you can take 47 also, doesn't really matter. So if the value of q is 48, then slope. Then let us find out the slope. So slope will be what? Slope will be, so that means here the value of q will be 48. So here the value of q will be 48. So that means in this equation value of q should be 48. So that means this one should be 48. this one should be 48. So if you calculate it exactly like the way it is here, you will get the value of the slope. So let me calculate 1171.5 plus 158.5 multiplied by 48 minus 3.75 multiplied by 48 square. So what we will get? What we get? 139.5. 139.5. Let me check if I have written it correctly. Let me check the calculation. Yes, it is correct. Always revise, to always spend 2 seconds immediately after you do every step. So it's correct. Yes. Right, it's correct. So it's correct. So where the value is 139.5, that means it's a positive. That means it is positive. So positive means what we can write, we need to write comment. Remember, if you don't write comment in the exam, if you don't write interpretation in the exam, you will lose lot of mark. So that the function or the function or curve is that means slope is positive. Slope is positive means moving up. The function or curve is moving up before the stationary point. So that means, as you can see, we have taken the value of Q 48 and at the stationary point value is 48.6836. That means before we have checked the slope before the stationary point. We have checked the slope before the stationary point and we found slope is positive. So that means the function or curve is moving up before the stationary point. So now we will check after the stationary point. So now we will check after the stationary point. So that means after the stationary point, slope will be any value higher than this one. After the stationary point, the value of Q will be after the stationary point, the value of Q will be any value higher than this one. So any value higher than this one. So let us take, you can take 49, you can take 50. So for simplicity, let us take 50. So here we will have 50, and again here we will have 50. So if you do the calculation, right, so we can see that the value is minus 278.5. right? That means negative. That means you need to write interpretation again. The function or curve is falling down. So function or curve is falling down, after the stationary point. After the stationary point. So that means we have checked the slope after the stationary point, because we have taken the value of Q 50 and at the stationary point value is 48.1. So that means we have checked the slope after the stationary point and we found it negative. So that means the function or curve is falling down after the stationary point. So that means the shape of the curve is like concave down. Shape of the curve is like concave down. So that means the stationary point is obviously the maximum point. That means we can conclude that the value of Q this one will lead us to maximum profit. So maximum profit. So that means if you produce and sell this many quantities of the product, it will lead us to maximum profit. Remember, we don't have any idea about the product nor about the business. So if decimal or fraction of the q is not possible, in that case you need to round it up. For example, if it is an aeroplane business, you cannot sell fraction of an aeroplane. So in that case you need to round it up. Right. So now let me prove it using second differentiation method. So now we will go for the proof using second differentiation method. In the exam I may ask any method. Right. So if you want to prove it using second differentiation method, obviously first of all you need to find out the second differentiation. That means you need to do differentiation for the second time. So if you want to do the differentiation for the second time, there will be 2 prime there. So that means here we will do the differentiation. That is, this is the one we got after doing first time differentiation. We need to do differentiation of this one again. So we will do differentiation of this one again. If you do differentiation of this one, this one has no variable, so this one is 0 plus, and here we have only one q there, so that means 158.5 q, sorry 5, minus 3.75 multiplied by, if you do differentiation of this one q square, you will get 2q. So which means, right, so what we get here, so after doing differentiation we got these one. So 3.75 multiplied by 2, 3.75 multiplied by 2 means 7.5 q. So 7.5 q. Right, 7.5 q. So this is what we got after doing second time differentiation. Remember, in the second differentiation method, we don't check the slope before the stationary point or after the stationary point. Here we check the slope of the slope function. Here we check the slope of the slope function at the stationary point. So we will check at the stationary point. So that means here we will check the slope at the stationary point. So q, the value of q will be 48.6836. So let me check if the value was 6, that one or not. Yes, 48.6836, correct. So the value of the q should be, we need to check the slope of the slope function at the stationary point in the second differentiation method. So the value of q will be the value that we got at the stationary point. So here for 48.6836. So if you calculate, let's see what we get. 0.5 minus 7.5 multiplied by 48.6836. Obviously it will be minus. So minus 206.627. So that means what we get, the shape of the curve is concave down. So that means what we can see, that the shape of the curve, is concave down. The shape of the curve or function is concave down. The shape of the curve or function is concave down. So that means we can prove that. That means we can conclude that the value of q is equal to 48.6836. The 48.6836 will lead us to maximum profit. So that's the evidence, that's the proof. So I have already showed you how to prove it using first differentiation method and also using second differentiation method. I have already shown you how to prove it using first differentiation method and also using second differentiation method. Right, the part E. If quantity demanded is at level Q max, then find the maximum profit and price of the product. Right, so that means we need to find out the maximum profit and the price. Right, so to find out the maximum profit, we will need the profit function. So to find out the maximum profit, we will need the profit function. So this is the profit function we have. So to find out the maximum profit, we will need the profit function. So we have already proved it. That when the value of Q is 48.6836, we have already proved it. When the value of Q is 48.6836, in that case profit is maximum. We have already proved it. When the value of Q is 48.6836, profit is maximum. So we will put the value of Q there. In the function. So here this is. So if you type it exactly like the way it is here, you will get the answer. So 1171.5 multiplied by 48.6836 48.6836 plus 79.25 multiplied by 48.6836 square. So 79.25 multiplied by 48.6836 square, and then minus 1.25 multiplied by 48.6836 cube. 48.6836 cube. So minus 1.25 multiplied by 48.6836 cube, minus 2000. So the answer is 98,631.8815. I don't know what's the currency. It may be dollar, it may be pound, I don't know, it may be taka, whatever. Anyway, the question didn't say any, didn't give us any information on that. So that's the maximum profit. So the maximum profit is equal to this one. So the maximum profit is equal to this one. So maximum profit is equal to this one. Now the question is asking us to find out the price also at Q max level. That means if you produce this much quantity of the product, at that level, if you produce and sell, this much quantity of the product, in that case what should be the price? Because you know that if the supply is more in the market, price should fall. If the supply is less, price should go high. If the demand is less, price will fall. If the demand goes up, price will rise, right? Again, if the price decrease, demand will go up. If the price increase, demand will go down. So these are the things you need to keep it in mind. Alright, anyway, so we need to find out the price. Question is asking us to find out the value of price also. So let us get the price function first. Alright, this is the price function. P is equal to, you can see this is what we got, price. So P is equal to 1200 minus 2Q. So P is equal to 1200 minus 2Q. Right? So 1200 minus 2 multiplied by 48.6836. 2 multiplied by 48.6836. 1200 minus 2 multiplied by 48.6836, which is 1100 to 6328. 63, that's it. So that's the price. Or the average, that's the average price. Or average revenue. That's the average price or average revenue. Right, so that's the end of the question 1. Right, so let us move to question number 2. Alright, so here what we have, when X thousand gallons of vegetable oil are produced, the average cost per gallon is this one. So this is the average cost per gallon function. So question is asking find the value of X that minimizes average cost per gallon. So obviously very easy question. So we will do the differentiation directly here. So that means this is the average cost function. We need to find out the value of X for which the average cost will be minimum, right? So we will do the differentiation first, right? So let us find out the slope. So slope is equal to, so we will do differentiation. When we will do differentiation, these will be like this, and we need to do differentiation with respect to X. We need to do differentiation of the average cost function with respect to X, right? So let's do differentiation. First. So first of all, we will do differentiation of this one. We can use the division rule of differentiation. If you use the division rule of differentiation, whatever you have in the denominator, you need to take a square of that one. Whatever you have in the denominator, you need to take a square of that one. And again, whatever you have in the denominator, you should get that one also again in the numerator. And then what we will do, we will do the differentiation of whatever you have in the numerator. And then we will have minus, and then whatever was in front of d by dx, that should go behind d by dx, and whatever was in front of whatever was behind d by dx should come in front of d by dx, should come in front of d by dx, right? Sorry, this one. So that means whatever you have in the denominator, you should take a square of that one. Whatever you have in the denominator, that should come also again in the numerator, and then you need to do differentiation of whatever you have in the numerator, and then we will have a minus. So the thing that you have in front of d by dx should go behind d by dx now, and the thing that was behind d by dx should come in front of d by dx now. So that's the differentiation for this part. That's the differentiation for this part. And then we will have what? We will do differentiation of this part. We will do differentiation of this part. That means we have 0.12. Right. So if you do differentiation of this one, we will get 0. So 0 multiplied by this 0, that means we will get 0 here. Right. And if you do differentiation of this one, right, you will get only 0.25. You will get only 0. Oops, sorry. So from this one we will get only this one. So that means if you do differentiation of this one here, you will get only 0.25. So 0.25, right. So what we get? So 1500. So 1500 minus 0.25, that means quarter of this one. So quarter of this one means like 375. 375. So we will have 375 here. So we will have 375 here, right? Right. So this is the slope function. This is what we got is the slope function, right? So we know that at stationary point slope is 0. At stationary point slope is equal to 0. At stationary point slope is equal to 0. So slope is equal to 0. That means this one is equal to 0. So this one is equal to 0. This one is equal to 0. So we will solve it. We will solve it to find out the value of x. So we will solve it to find out the value of x. If you move this one to right hand side, minus 0.12. So that means if you move this one to right hand side, we will have minus 0.12. And we can see that we have minus in both sides. So both the minus will cancel each other out. So minus, we can see both sides we have minus will cancel each other out. Now we can do cross multiplication. According to cross multiplication rule, the cross items can replace each other's position. So this one can go here, and this one can go here, and this one can come here in this position. So according to cross multiplication rule, cross items can replace each other. Cross items can replace each other. So this one can go there, and this one can come here. So under cross multiplication rule, cross item can replace each other's position. So let us divide this one. So we can write we can write this one on the left hand, we can write this one on the left hand side. We can write this one on the left hand side is equal to, let's divide this one. Let us divide this one. 375 divided by 0.12. So we will get 3125. 31325. So 3125. Right. So now we will take square root in both sides. So now I will take square root in both sides. So if you take square root in both sides, what we will have is root over 3125. So root over 3125. So root over 3125 means what? So root over 3125 means 55 point. So root over 3125 means 55 point. So root over 3125 means 55.9017. Right. Right, it's correct. So now what we will do, we can move the 8 on the right hand side. If you move 8 on the right hand side, so this one minus 8. So this one minus 8. So what we will have, 47.9017. So 47.9017. Right. So now what we will have, x is equal to this one divided by 0.25. So right, so this one divided by 47.9017 divided by 0.25. So what we will get, 191.6067, right? 191.6067 or 6068. Anyway, so this is, let us check the unit of x. So x is 1000 gallons. X is 1000 gallons. So x is 1000 gallons. So you need to write the unit here, 1000 gallons, right? So x is 1000 gallons. Right, so this is we got the value of x. Now the question is asking us to prove it. So the question is asking us to prove it. So let us prove it. So obviously to prove it, we know that two method is there. So to prove it, we can use first differentiation method, we can use second differentiation method, we can use either of the method, right? So let us prove it. So proof. So proof, if you want to prove it using first differentiation method, so if you prove it using first differentiation method, what we will have, right? So if you want to prove it using first differentiation method, you need to check the slope before and after. So the value of x, we got 191.6068. So we will check it before and after. So if the value of x is equal to 191, if you take the value of x 191, in that case what will be the value of slope? So the value of slope will be equal to So here the value of x will be 191. Here the one nine one. So if you calculate, you will get the value. Let us calculate. So what we have here is 0.25 multiplied by 191 plus 8. 0.25 multiplied by 191 plus 8, bracket close, square, right, plus 0.12 plus 0.12. So what we will have is, we can see that we get an answer in power. So when you get an answer in power, you have to press. When you get an answer in power, you have to press Shift ENG. If the power is negative, you will press Shift ENG. Again Shift ENG until it comes to 0. So here the value is 0.00065. So obviously negative. So that means the negative value. So we can write the comment is the function or curve is falling down before the stationary point. So now we will check after the stationary point. After the stationary point. So we will take the value. We can take the value 192. We can take the value 193. Let us take 193. So here we will have 193. So if you calculate, you will see the value is, so 193, right? So here if you press Shift ENG, you will get until you get power 0. So here we get 0.00148. So again, so this is positive. So what we can write, the function or curve is moving up after the stationary point, after the stationary point. That means the shape is like concave up. That means, right, that means we can conclude that the value of, that means we can conclude that 100 and what's the value of X? $191,6068,000. You need to write the comment very nicely. So we can conclude that, so 191,6068,000 gallons of vegetable oil production and sale will lead us to minimum average cost. So will lead us to minimum average cost, right? So because this is a cost, you don't need to write sell here, right? Because you don't want to find out the profit here. It's a cost. So we can conclude that 191.6068 thousand gallons of vegetable oil production will lead us to minimum average cost. Minimum average cost. So it's we have already proved it. You can prove it using second differentiation method. I'm not showing you because you know how to do it. You do it on your own at your home, right? Right. So right. So now the question is asking compute the minimum average cost. Compute the minimum average cost. So minimum average cost. So this is the average cost function. This is the average cost function. So we need to find out the minimum average cost. So this is the average cost function, and we have already proved it. We have already proved it when the value of x is 191.6068 thousand gallons. In that case, average cost will be minimum. We have already proved it. So here, when the value of x so 191.6068. Let me check it again if the value I have written correctly, because you need to check it. Yes, x is 191.6068. 191.6068. Right. So here the value of x is, oh, I don't want to type. Let me copy. I'm a very lazy person. Let me use technology. Right. So now if you calculate, you will get the value. So 1500 0.25 multiplied by 191.6068 plus 8 plus 0.12 multiplied by 191.6068, so is equal to what we will get, 49.82 49.8256 right, 49.8256. right. So let us check the unit of this one. Right. So average cost, right? Okay, average cost is dollar per thousand gallons. Dollar per thousand gallons. So average cost unit for average cost was dollar per thousand gallons. So obviously this one will be dollar per thousand gallons. So dollar sign is dollar. So dollar per thousand gallons. Per thousand gallons. So that's the answer. So that's the final answer. All right. So that's the answer. So that's the end of this lecture.